This is just a very short video to make one additional comment on Lecture 21. Here we see the very end of the problem that we were considering in Lecture 21. And you will recall that the polar plot for the magnitude of f of theta in the xz plane is as shown here, and the polar plot for the element pattern, the magnitude of the element pattern in the xz plane was shown there. And so we said in Lecture 21 then that the complete pattern that we obtain when we multiply those two together is shown here. And I'd just like to make just a very minor modification in this complete pattern. Notice that the element pattern is going to 0 at theta equals 90 degrees, whereas the array pattern has a maximum very close to that angle. It's not quite at pi over 2, but it's close to that. And so when we multiply, because of this 0 at theta, because of this 0 in the pattern of the element pattern at theta equals pi over 2, when we multiply this element pattern by the array pattern, we get a 0 in the complete pattern, as you can see right here. The only change that I want to make here in the complete pattern is that these two lobes here are a bit larger than they really should be, and let me explain why. This lobe here is being split in two by this 0, but even when we move a little bit off of the angle of pi over 2, this element pattern has a small value. As you can see, if we go just a few degrees to the right or a few degrees to the left of pi over 2, this element pattern is still rather small. And so when we multiply the element pattern by the array pattern for angles close to pi over 2, we will still get a small result. So probably I think that we should make note of this. Even though these graphs are sort of rough graphs, we can make this a bit more accurate in the following way by making these two lobes a bit smaller. And that's a bit more realistic picture for the complete pattern of this array. Of course, if we wanted to get an absolutely accurate picture, what we should do is plug into our formulas recall here we go. Here is our formula for the complete pattern. And so if we wanted a completely accurate picture of that in either the xz plane or the yz plane, we could then set for xz we could set phi equal to 0, for yz we could set phi equal to pi over 2, and then we could get completely accurate values for f of theta and phi. But if we want just a rough plot, then this is a bit more accurate than what we had before. And so that concludes this minor addition to Lecture 21.